A couple of basic examples on this work. If theta is small, you're told in the question, and it's measured in radians, find approximations for the following two expressions. So let's do the first one, number one. This is going to be approximately the same as theta multiplied by, now sine theta is approximately the same size as theta if theta is small and in rads. So we're going to get theta times by theta, which is obviously going to be theta squared in a minute, all over cos of 2 theta. So it's 1 minus, now you should know that the cos of theta is approximately 1 minus theta squared over 2. So the first thing you should realise is if I'm dealing with 2 theta instead of 1 theta, well, first of all, if theta is small, 2 theta will also be small, so you can still use this approximation that cos 2 theta will be approximately 1 minus, not theta squared, but 2 theta all squared over 2. So if you think about this, cos of 2 theta is going to be 1 minus, if you square 2 theta you're going to get 4 theta squared, share by 2 you're going to get 2 theta squared. So you're going to get 1 minus 2 theta squared on the bottom line, because this is 4 on the top, 2 on the bottom, the 4 and the 2 will cancel. Just tidy this up, so this is approximately the same as theta squared on the top over 1 minus 2 theta squared on the bottom. And that's it. So if theta is small, measured in radians, that expression is about the same size as that expression there. Just be careful, you cannot cancel theta squared and theta squared top and bottom there. If you were going to share the top by theta squared to get 1, you'd have to share both these terms on the bottom line to get 1 over theta squared and then minus 2. But obviously that's not what we need to do. This is the neatest form of the answer. So that's approximately the same as that. And that's the end of that question. Okay, so number 2, same sort of thing. This is approximately, let's move this up a little bit, theta times by, well, I'll save a line of calculation here. Tan theta once again is approximately the same size as theta if theta is small in radians. So you're going to get theta times theta, which is theta squared, all over 1 minus cos theta. Well, cos theta itself can be replaced with 1 minus theta squared over 2, provided, of course, that theta is small and measured in radians. So we get that expression. So this is approximately the same. Let me just check that this is still in view. Okay, so we're fine. So this is approximately the same as theta squared over, if I expand that bracket out, you get 1, minus times the 1 is minus 1, and then minus times the minus is plus theta squared over 2, like so. So this is approximately the same as theta squared on the top over 1 minus 1, the two 1's will disappear with each other, so they vanish, leaving you with just theta squared over 2. Okay, so very quickly now, this is approximately the same as theta squared on the top. If you divide by that fraction, it's the same as multiplying by the fraction upside down. So we get times by 2 over theta squared. So this is now nice easy calculation. Put that over 1. Share the top by theta squared, it goes 1. Share the bottom by theta squared, it goes 1. So you get the cancelling there, top and bottom. So the answer is approximately equal to 1 times 2 is 2, over 1 times 1 is 1. So there you go, the answer is approximately 2. So for theta tan theta over 1 minus cos theta, if theta is measured in radians and is small, it's approximately the same as the value 2. And that's the end of those two very straightforward calculations.